In this video, we'll compute a power spectrum of a grayscale image created from a formula. So here we'll click New 2-Dimension, and let's look at large size. Graph, edit points used. I'm going to use that many, 512 by 512 it'll be. Plot. Now, previously I entered this formula in, so now we'll click plot, get that result. Now I want an actual true grayscale image, 8-bit image. This has decimal values in it because of the cosine and sine, but we can click Graph, Quantize, make an 8-bit image from the data we have there. Plot. And it looks basically the same. All it's doing is rounding to the nearest whole number. This is between 0 and 255. Truncates if it's greater than 255. And if it's less than 0, changes it to 0, as discussed in the class. Let's look trace here. And you can see now the readout, all 8-bit integer values there. Let's compute the power spectrum of this. That. And it's best really to, if we're going to zoom in like I intend to, we're going to clip this out. And now change graph style to log. I'll do this one, gray plus or minus. And there we can see. Probably I didn't need to zoom in so much on the original there, but to see a little bit more, we will zoom in now. 256, 256. And there's the power spectrum. And in relation to the original graph, we have a 2010 frequency information that corresponds to about here. 2010, right? And then we also had minus 4030. That would be about over here, minus 4030. There we have information there. And there's a certain symmetry about the origin that occurs in the power spectrum. But we've done several examples discussing that point. Notice there also is a central value there. And that's 18,225, which turns out to be the square of the 135 value here, and that's discussed in the course why that happens. So there we have a power spectrum for this grayscale image there, and it's discussed in the course how that relates to the appearance of the image. Okay. Thank you for watching.